And what we're going over today, we're going to start on the next assignment, which again, you've already done. It's the mole conversions assignment. This is where we start to use some of the math and actually do some of the problems. And this is basically like the very beginning of stoichiometry. They don't actually call this assignment stoichiometry. It's just simple mole conversions. But this is the basis for it. And we're going to take this chart, which I also have drawn on the board over there, and we're going to add a couple more things to it, which is just going to make it harder and harder and make the problems longer and longer. So if you know how to use this chart, that is very good. You also want to understand why this chart is set up the way that it is and try to, you don't have to memorize it, but understand the names for the words and what they're doing. And once you do that, you will kind of be able to memorize what you need to do without using the chart. And the reason I say that is this chart is just going to get expanded and become more and more complicated, and the problems are going to be pretty difficult. One of the problems that we run into when we get to stoichiometry is the problems take y'all so long to do, not because you're doing them slowly or anything. It's just a long problem. We like that quick, like instant gratification. Like I do the thing, I get the answer, I get the question right, and I move on. When it takes you like 5 minutes to do a problem and then you put your answer in and it's wrong, y'all get very let down, you know, and you don't want to, like, I don't want to have to go back through 5 minutes of work and try to get to the correct answer. And so one of the things I'm going to stress starting now and moving forward is that y'all use scratch paper, that you write stuff down in scratch paper. This assignment, you can easily do this assignment on your Chromebooks or on the calculator without writing things down. But I want you to start to write stuff down, because here's the thing. If you don't write anything down and it's all in your calculator, once we get to the more difficult problems and you ask me for help, I don't have any way to help you because I have no idea what you've done and what numbers you've put in and how to figure out what you did wrong. If everything's written down and I can see each step that you've done and the numbers that you have, that makes it much, much easier for me to come in and look at your calculator. And a lot of times you just put the decimal in the wrong place or you divided where you should have multiplied. And that's super easy for me to see. And I can just tell you, oh, just literally change this division to multiplication and now you're good to go. But if none of it's written down, I can't see any of it. And it makes it much, much harder to figure out what's going on. So please pull out a sheet of scratch paper. If you need scratch paper, I always have scratch paper for you. So try today to start to write some of these numbers down and keep track of your math. It'll help me help you. It also help you by seeing each of these different steps and kind of understanding what they are instead of just putting numbers in the calculator and expecting it to be right. Because we're getting to the point now, you have to like become more familiar with making mistakes. A lot of you are going to make a lot of mistakes doing this, and that's not a problem because this is very difficult to do. The problem is when you get to that first mistake, can you work through it and figure out what you did wrong? Or are you like, I don't know, it wasn't right, I'm stuck, I have no idea what to do. That's what we're looking to do, is be able to work through those problems. So what we have today, along with this kind of setup, which I will post all this online for the few online people. There's nobody in this class, but I'm recording for the online people. Right now, we're switching between three different things, right? We have mass, which what is mass? When I say mass, what am I talking about? Weight, yes. And for all intents and purposes, as long as we're on this planet, when we say mass, we're talking about weight. We put things on a scale. We weigh how much it weighs. And what's the unit we use for mass? Grams. So we're looking for something in grams. And for the most part, you can expect your answer in grams to be reasonable. I don't know that there's any sapling problems where they're like, yeah, if you've got like 1 million grams or like 1 billion grams. Usually your grams are going to be like in the tens or the hundreds, maybe the thousands, but usually not even that heavy. You're going to have a regular, simple answer for grams. We also have moles, which we just kind of learned about. We just introduced. But a mole is just a number of things, like a dozen, right? Except the number's really, really big. So when you have moles, yeah, the number's large, like this 6.02 times 10 to the 23rd, but that's not my number of moles. If I have this many things, I only have 1 mole. So when you get answers in moles, they should probably be a reasonable number too. 1 mole, maybe less than a mole, like 0.5 moles or 0.7 moles. Maybe like 2 or 3 or 6 moles. But if I have like 5,000 moles, that's probably a little bit big for the answer. I want it to be a regular kind of simple number, just like grams in a way. So moles should be a regular number. Now, particles, what do they mean by particles? Atoms, yeah. Literally anything that's tiny in chemistry, they have them listed over here. Atoms, molecules, formula units, which is just another way to say molecules. Also in here, technically, could be ions, like positive ions, cations, or anions that are negative. You could use protons, neutrons, electrons. There's all sorts of things you can have over here. They might need an extra step or two, which we'll see in a little bit. But particles are your really tiny things that are going to be expressed in really large numbers. So remember yesterday, I already put them away, but each of these bags had Avogadro's number worth of particles, which is a really, really big number, right? So every single one of these bags had that number of particles in it. So we expect if they ask you for particles or atoms or molecules, I'm not going to have like 5 molecules. That's not something we're counting. If you answer in atoms or molecules, it should be a really, really big number, close to the size of Avogadro's number. Maybe a little less, maybe a lot more. But it's going to be somewhere around that kind of size number. And if you get something really small, like 100 or 500, that's not the right answer for particles. And so just thinking about the size can help you out sometimes to make sure you're in the right area. The other thing I want to look at is how we're moving from these answers. And that's our whole job here. I need to go from mass to moles, or moles to particles, or particles back to mass or moles. So I can go anywhere from one of these 3 to either of the other 2. And what do I use to get there? I have 2 tools that I use to convert. The first one is the molar mass, which the molar mass, right in the name, tells you that it converts in between what 2 things? Moles and mass, yeah. So if they're asking about particles and you need to get to particles, you're not going to use the molar mass to get over to particles. Molar mass is only going to get you from the mass to the moles or the moles to the mass. And where do I get the molar mass from? Periodic table. That's what we were looking at yesterday when we saw that all of the bags matched up with the number that was at the bottom of the box on the periodic table. So when I looked up hydrogen, it was 1.008. When I looked up oxygen, it was 15.999. That's the molar mass. And what that tells you is it's the weight in grams of 1 mole of whatever substance you're looking up, whatever element you're looking up. If it happens to be like water, like H2O yesterday, we had to add up those 2 parts of it. 2 hydrogens and 1 oxygen, we added it up, but that was still the weight of 1 mole of water. From there, I can figure out how many moles I should have, do a little bit of math, and figure out either how much the total weighs or how many particles I have in that many moles. So, molar mass converts from mass to moles, moles to mass. And what are my 2 different options for how I use the molar mass? Divide or multiply. So notice on the left side, I have molar mass. On the right side, I have Avogadro's number. As far as dividing or multiplying, on the top, both of them are dividing. On the bottom, both of them are multiplying. But the arrows don't necessarily go the way maybe you would want them to go. I would think if I'm going left, I have 2 left arrows on top and then 2 right arrows on bottom. But they did a little bit differently. That's okay. Make sure you're paying attention to which direction the arrow goes so you're moving the right way. So like if I want to go all the way from mass, if they give me mass and they want me to go to particles, first step, I divide by the molar mass. The answer I get when I divide by that molar mass is no longer mass. I now know how many moles I have. And to go from moles to particles, I go along the bottom. I'm going to multiply by Avogadro's number. the answer I get should be pretty big because I'm multiplying by a big number. That's going to take me over to particles. So this is like your roadmap. Now, the further we get along from this assignment, the roadmap will get longer and longer, and the steps won't be as certain. Once we get to a certain level on here, it's not like a straight up formula that you'll be able to follow kind of like this. You're going to have to interpret some things and kind of learn what comes next. But we'll get to that once we get to that. So that's what we have for today. I think that I don't want to talk too much and add too much stuff. Before you open your Chromebooks, let's do one example. Everybody close real quick. We got this example here on the board. Let's see. Oh, I'm on freeze. Okay. Then everybody can start. Close Chromebook, Rocky. All right. And I've already done this example on the board, but I just want to show you all again. So, yeah. So they're giving us molecules. So once we start to do these and y'all ask for help and I come over, there's two things I want to know from the very beginning. And you should be able to tell me. What's the number they give you and what's the answer they want from you? So looking at this question, the number they give me is what? And I don't care necessarily about the number because all your numbers are going to be different. But what's the unit they're giving me? Molecules. Molecules. Which molecules is going to be which of these three? Particles. I'm starting at particles. And then what do they want from me? What answer do they want from me? Mass, which I need to go all the way over to mass at the very end. So I need to take two steps here. I'm starting at molecules, which is particles, and I'm going over to mass. I need to make these two steps, which are going to be one, divide by Avogadro's number, and when I do that, my new answer is moles. And then step two, I need to multiply by my molar mass, which is going to take me to mass. So when I do that, let me do it on the board over here so everybody can kind of see. I start off with 7.00 times 10 to the 33 molecules. 7.00 times 10 to the 33. I'll write molic because it's not moles, it's molecules. And what's my chemical I have here?
H2O.
H2O. Now, what's the first step that I need to do to go from particles to mass?
Calculate molar mass.
I need to divide by Avogadro's number. I need to take Avogadro's number and I need to divide by it. Now, I can just go ahead and put this underneath if I want to. I'm going to start to set this up like we need to in the future. I'm going to do it like this. I'm going to divide by 1. Because dividing by 1, does that change anything? No. And I'm going to set this up with another fraction. And you'll see why I do this in a little bit. I want to keep track of all of my units. So when I do Avogadro's number, it tells me the number of particles in what? 1 mole. So that's very important because what I'm doing is converting here from units. So I'm going to put 1 mole on top, 1 mole of water. And how many particles are in 1 mole of water?
6.
Avogadro's number, right? So Avogadro's number is going to go on the bottom, 6.02 times 10 to the 23rd power. And this is molecules of H2O. So now what's going to happen here? This molecules of H2O is going to cancel out with this molecules of H2O. I don't write molecules there, but that was the unit for how many particles or molecules are in 1 mole. So when that unit cancels out, top and bottom, what's the only unit I have left? But H2O is a chemical, but what's the unit? Moles. So once I do this step, now I have my answer in moles, which I can use to get over to mass. So if I take my calculator, because we're dividing, I'm going to put this in brackets, open bracket, 7.00 times 10 to the 33 power, close bracket, divide by, because this is on bottom. So are all y'all familiar with like putting fractions together? Like I'm multiplying these, but technically I could just erase that and like finish this line across. And this is on top, this is on bottom, so I'm dividing, right? Is everybody okay with that? Okay. Math gets weird. There's all sorts of weird math tricks that you can use. So I need to divide by Avogadro's number. Divide by open bracket, 6.02 times 10 to the 23rd power, close bracket. And what's the answer I get? I get a lot of moles. Is that right? 33 divided by the 23.
All right.
That's a big number. So normally we don't get a lot that many moles. It seems like a lot of
You
moles.
think you're right?
I don't know. I think I am, yeah. But
Let me see for sure.
it's an answer that would make me like have a second guess, and I'd be like, is this actually right? So what I got on my calculator is 1.16 times 10 to the 10th power, which is a lot of moles. That's quite a bit of water there, or at least it's not a small amount. Now, what's the second step that I need to do? Now I have moles. I know how many moles I have. What's the second step that I need to do?
Multiply by molar mass.
Multiply by the molar mass. And where do I get the molar mass?
You put it from the periodic table.
I get it from the periodic table. So what's the weight of one hydrogen?
1.0.
1.008.
And how many hydrogens do I have in water?
Dose.
2. So I have 2 of them. And then what's the weight of oxygen?
15,999.
999. And we added this up the other day. It's like 18.015. So that's my weight for water. This is, so remember, molar mass is the weight of 1 mole of water. So I have 1 mole and 18.015 grams. If I want to get rid of 1 mole, what goes on the bottom of the next one? 1 mole. Because if it's on top and bottom, I can cancel it out. So I have 1 mole of H2O on bottom and 18.015 grams of H2O. So now I have this complete thing, and what do I need to do? We already said it, but here I'm multiplying by the molar mass, right? So if this is on top, I'm going to multiply. If this is on bottom, I'm going to divide by it. So I've already did my division here. Now all I need to do is multiply by the molar mass. So I'm going to take my answer times 18.015, and I get 2.09 times 10 to the 11th power? Yes. 11th power, which I don't know. I feel like that's not right. Let's see.
I don't think it is. I think you're wrong.
Let's see if I got it right. So they gave us the steps. We got the steps right. Yeah, no, I got it right. I feel good about myself now. No, I got it right. 2.09 times 10 to the 11th power. And so this is your sample problem to kind of see what are the steps that you could do, how you're going to do this. I do have this written down. The people online didn't get to see this. So if you're online and you'd like to see how I did it, there's my setup. We can see they're using the fractions the same way that I did. If we need to divide by something, we set it up in a fraction and we put the division part on the bottom. We need to multiply by something, we set up another fraction and put the multiplication part up top. So that's going to help us get to the correct answer. So I guess that's it today. I don't want to talk too long, confuse everybody. Go ahead and get started. If you didn't finish the assignment yesterday, do that first. Finish the assignment from yesterday and then start on this assignment, and you should be good. If you have any questions, please let me know. And did that stop? I am going to check right now and see if I got a login for you.